Project: Hypothesis Testing on Real-World Datasets. Welcome to this beginner-friendly hands-on project. You will learn how to use Python to do basic probability and hypothesis testing. We will use real data from a restaurant's tips to test ideas about how people tip. You do not need any prior experience. Let us start this journey into data. Running the cell now. Let us load the dataset for our project. We need a real dataset for hypothesis testing. Here we are importing pandas for data handling and Seaborn for datasets. We are also suppressing warnings so you see a cleaner output. Pandas helps us work with tables of data. Seaborn gives us access to real sample datasets. Import NumPy as NP. We set the random seed to 42 for reproducibility. We load the restaurant tips dataset from Seaborn. Each row is a dining bill. We print the shape of the data so you can see how many rows and columns there are. Now we print the first few rows to get a sense of the data. This helps us make sense of what columns exist. Running the cell now. This output shows the shape and first few rows of the tips dataset, which contains 244 records and 7 columns, including total bill, tip amount, and customer details like sex and smoking status. Noticing this structure is key because it sets the foundation for later hypothesis tests where you'll explore relationships between these variables. The intent of this code was to familiarize you with the dataset's basic layout before diving deeper into probability and testing. Take a moment to look through the columns. Can you find the column that records the tip amount? What data are we using? This dataset has information about restaurant bills, tip amounts, days, and whether the diner is male or female. Each row is a meal served in a US restaurant. You can see columns for total bill, tip, sex, day, and time. Today, we will use this dataset to check if people tip differently based on certain factors. Running the cell now. Let us check what columns we have and if there are any missing values. We print out all the column names so you know what data we can use. This line prints the list of column names from the tips data frame. Now we check for missing values in each column. This means, are there any blanks or empty spots? We print this for each column to see if any need cleaning. Running the cell now. This output shows the basic structure and completeness of the restaurant tips dataset, listing all columns and confirming there are no missing values in any of them. This is important because it assures us that every row has full information, so we can proceed with analysis without needing to handle missing data. Notice if any columns have missing values. If so, we should handle them soon. If there are missing values, let us remove those rows. This makes our analysis more reliable. Here we safely drop any rows with missing data. This is a common step before analysis. We overwrite tips with the clean data. Printing the new shape shows us how many rows remain after cleaning. Running the cell now. After removing rows with missing values, the dataset now has 244 rows and 7 columns, confirming we cleaned the data without losing too much. This step ensures our analysis uses complete records, so calculations on bills, tips, and other features will be accurate and reliable. Now our data is clean and ready. On small datasets, losing a few rows is often okay. Problem statement. Suppose we want to answer, do male and female customers tip differently on average? We will use tip and sex columns for this. This is a perfect place to use a hypothesis test. Running the cell now. Let us look at a plot to compare tip amounts for males and females. We are importing matplotlib so we can make charts. Seaborn helps us create a colored histogram by sex. This shows how tip amounts are spread for male and female customers. The title and axis labels make the chart easy to understand. The x-axis is in dollars for each tip. The y-axis is density. This means the height shows how common different tip sizes are. We add a legend so you can see which line is which group. Finally, we show the plot so you can see the difference. Running the cell now. This histogram compares the distribution of tip amount separately for male and female customers. Notice how the shapes and peaks of the two distributions differ, which helps us visually assess whether one group tends to leave higher or lower tips on average. This aligns with the lesson's goal of exploring tipping behavior by sex to inform further statistical comparison. Can you spot any difference in tipping patterns between the two groups? Hypothesis testing. A hypothesis test lets us check if any observed tip difference between male and female diners is likely to be real or just happened by chance. Our null hypothesis says both groups tip the same, on average. Our alternative hypothesis says males and females tip differently, on average. Running the cell now. Let us see the average tip for each group before we try a formal test. Here we find the average tip for males and females. We use group B to separate them and mean to find the average. Printing the averages gives us a first clue. This shows if the groups seem different before checking if it is real. Running the cell now. The output shows that, on average, male diners tip about $3.09 while female diners tip slightly less, around $2.83. This difference is what the hypothesis test will evaluate to see if it's statistically significant or just due to random variation. Noticing this average difference is key to understanding what the test is trying to confirm or reject. Is there a noticeable difference in average tips between men and women? Now, let us use a t-test to compare the two groups. The t-test is a common way to compare means from two groups. It is good for small or medium data. We import the test_int function from the scipy.stats library. We get each group's tips as a separate variable using pandas. We run the t-test using the two groups as input. This gives us test statistics. We get two outputs, t-statistic and the p-value. The p-value tells us about evidence. We print out the t-statistic, which measures the size of difference compared to random variation. The p-value shows the chance of seeing a difference this big if there was actually no difference. Running the cell now. The output shows a t-statistic of about 1.39 and a p-value of 0.17, indicating that the observed difference in average tips between male and female diners is not statistically significant. This means the data does not provide strong evidence to reject the null hypothesis that both groups tip the same on average. The key takeaway is that any tip difference we see could easily be due to chance rather than a real underlying difference. Remember, a p-value below 0.05 usually points to a real difference. If it is higher than 0.05, the difference could be just random luck. Let us check our t-test decision using a rule. If the p-value is less than 0.05, we say the difference is likely real. The alpha is our decision level. Here, alpha is 0.05, which is very common. We check if the p-value is below or above alpha. If it is smaller, we reject that the averages are equal. We have evidence of a difference. The print statement explains this choice in clear language. If the p-value is bigger, we keep our first idea. No real difference can be shown now. Again, the print line makes this choice clear for the reader. Running the cell now. This output tells us that the p-value was not small enough to conclude a significant difference in tipping between males and females. In the context of hypothesis testing, it means the data does not provide strong evidence to reject the idea that both groups tip the same on average. This is key for understanding how statistical tests help confirm or question our assumptions. Try changing the column or groups to test other ideas like day or smoker. Why does this work? The t-test checks if averages are probably different in reality. Random data can be misleading. The t-test helps us know if our results could just be luck. A p-value below 0.05 means there is less than a 1 in 20 chance the result is just randomness. Note, if groups are very unequal or non-normal, more complex methods can be used. Running the cell now. Let us try a small project where you pick which groups to test. We will use input to let you choose columns and group names. This is a prompt to try the code yourself. Ask the user to choose a column to split the data by, like sex or smoker. Ask the user to enter the first group name from that column. Ask the user to enter the second group name to compare against the first. Select the tip amounts for the first group based on user input. Select the tip amounts for the second group similarly. Perform a t-test comparing the two groups' tips. Print which two groups are being compared. Print the t-statistic from the t-test. Print the p-value from the t-test. If the p-value is less than 0.05, it means there is a significant difference. Print a message indicating a significant difference. Otherwise, indicate there is no significant difference. Running the cell now. This output shows the t-test comparing average tips between smokers, yes, and non-smokers, no. The very high p-value, 0.93, means any difference in tip averages is likely due to random chance, so there's no significant difference here. This confirms that the t-test helps us avoid jumping to conclusions just based on small or random variations in the data. Try doing a test using smoker and enter yes and no to see if smokers tip differently. Challenge yourself, can you try all the columns? Let us see how the mean tips look on each day of the week. We will print out mean tip and how many meals are recorded for each day. This little loop goes through all unique days in the data. For each day, we grab tips for just that day. We then print out the day's name, mean tip, and count of meals. Seeing the mean tip for each day helps us spot patterns. Running the cell now. This output shows the average tip amount and the number of tips given for each day of the week, helping us see if tipping behavior varies by day. Notice that Sunday has the highest average tip with a substantial sample size, while Friday has the lowest average and the smallest count, which could affect the reliability of comparisons. These summaries set the stage for the t-test, which will determine if these differences in averages are statistically meaningful or just random chance. Do you see any day that stands out? Which day has the highest average tip? To check if tips really differ across days, let us run an ANOVA test. ANOVA is like a t-test but for 3 or more groups. First, we import ANOVA from scipy.stats. It is called f_1 way. We gather the tips for each day into a list using a loop. We run the ANOVA test using the list as input. This checks for significant differences. The test outputs the f-statistic and the p-value. We print both so you can see them. A low p-value means at least one day is different in tips. Running the cell now. This output shows the results of an ANOVA test comparing tip amounts across different days. Notice the p-value is 0.174, which is above the usual significance level, meaning there's not strong evidence that average tips differ by day. This connects to the lesson by highlighting how statistical tests like ANOVA help determine if observed differences are likely real or just due to random chance. If p-value is below 0.05, it suggests at least one day has tips that are different. Want more practice? Try comparing lunch and dinner tips too. Let us see a box plot to visualize how tips spread out on each day. This comment explains that the plot will be a box plot showing tips grouped by day. We set the size of the figure to be 8 inches wide and 5 inches tall. We create a box plot using the tips dataset, showing tip amounts for each day with different colors. We add a title to the plot to describe what it shows. We label the horizontal axis to indicate it represents the day of the week. We label the vertical axis to indicate it shows the tip amount in US dollars. We display the plot so it appears in the output. Running the cell now. This box plot shows the distribution of tips received on each day of the week, revealing differences in median tips and variability. Notice how some days have higher median tips and wider spread, which sets the stage for the t-test to determine if these observed differences are statistically meaningful or could just be due to random chance. This visualization helps us intuitively assess whether the t-test is necessary to confirm if tip averages actually differ by day. Box plots are great for viewing spreads and spotting big differences at a glance. Try making a box plot for tips by other columns like sex or smoker. Extra tips for hypothesis testing. Always check for missing data first. Choose the test that fits your question, t-test for 2 groups, ANOVA for more. Visualize your data before and after testing. Do not forget to consider random chance. Keep practicing with different questions and datasets. Running the cell now. If you make a mistake in the column name, Python will give an error. Let us see what kind of message appears and how to handle it. This is a comment explaining the example is about common mistakes and troubleshooting. We begin a try block to attempt the code that might cause an error. We attempt to select rows where a non-existent column bad_col equals broken, which will cause an error. If an error occurs, the except block catches the exception and assigns it to variable e. Print a user-friendly message indicating that the column was not found and to check spelling or column names. Print additional details about the error using the exception variable e. Running the cell now. This output highlights a common error when referencing a column that doesn't exist in the dataset, emphasizing the importance of checking column names and spelling before running hypothesis tests. Catching such mistakes early helps ensure your data selection aligns with your research question and prevents confusion in later analysis steps. This reinforces the lesson's tip to always verify your data structure before proceeding. If you see an error, double-check your column spelling or use tips.columns.tolist. You are doing great. Troubleshooting is part of the process. Challenge, your turn. Try running your own hypothesis test on this tips dataset. Can you find any other interesting differences? For example, compare lunch and dinner tips or smoker and non-smoker tips. Share your results or questions in the comments, and do not forget to subscribe for more tutorials. Running the cell now. Recap and next steps. Great job! You learned how to load real data, clean it, visualize it, and run basic hypothesis tests. Hypothesis testing lets us check if 2 or more groups are probably different in reality, not just by random chance. Try these steps on your own data or other datasets. See you in the next video and happy learning. Running the cell now. Thank you for learning with us. If you found this lesson helpful, please click the like button and subscribe to our YouTube channel for more beginner Python and data science projects. Comment your favorite part or share your own tip analysis. Let us keep learning together. Running the cell now. Nice work finishing this beginner project. Keep going and experiment with your own data. Do not forget to like and subscribe for more simple Python data tutorials.